Every SAT, the same thing happens. Some students walk in confident, prepared, and ready to crush the test. Others, they sit down, see the first question, and their mind goes blank. It's like the College Board is trying to play a game they don't know the rules to. But here's the truth. The SAT is predictable. The same question types appear over and over again, just disguised in different ways. The top scores is they've cracked the code. And that's what this video is about. I've analyzed past tests, I've broken down the trends, and right now I'm gonna show you the exact types of questions that you're expected to see on the May 2025 SAT. You have an equilateral triangle, equal sides, equal angles, with a perimeter of 876 centimeters. But here's where it gets insane. The triangle is inscribed in a circle. That means all three vertices touch the circle perfectly. And they want us to find W when the radius equals W multiplied by the square root of 3 centimeters. Most students would panic right now, but not you. So firstly, we should find the side length. So this is an equilateral triangle, which means all three sides are identical. So perimeter equals 876 centimeters, and side length would be 876 divided by 3, which equals 292 centimeters. Now we have to find the connection between the side length and radius. So when an equilateral triangle is inscribed in a circle, there is a magical relationship. Radius equals side length divided by the square root of 3. This is the formula that can change this SAT question. So the formula that can take you from being a struggling student to crushing these types of problems. So here we have R equals 292 divided by the square root of 3. So now we know that R equals W multiplied by the square root of 3. So 292 divided by the square root of 3. And this will equal to W in the square root of 3. So 292 equals W multiplied by 3. So W equals 292 divided by 3. The sentence that we care about here says any graduate from the boot camps who arrive in San Francisco with a prototype in their laptop could take no shorter road to seeing it develops than that, which led to the office of Dr. Markova. So let's pull out some keywords here. No shorter road, which is the underlying portion here. And this means that going to Dr. Markova was the best option. If you want to develop your idea, seeing it developed, this tells us what she does. She helps programmers bring their ideas to life. So here, our conclusion or summary of the sentence is that if you wanted your app to succeed, going to Dr. Markova was the best move. Now let's understand the role of this sentence, because when we have a phrase that is underlined, it's more about the sentence than just about this word. Now let's think, why does this author include this? What does it tell us about Dr. Markova? So the passage says she welcomes everyone, even if their ideas are not amazing. She's brutally honest and doesn't sugarcoat her feedback. But despite her bluntness, people still go to her because she's important. So our summary here that Dr. Markova is a big deal. If you're a new developer, getting help from her is a game changer. So now let's try to eliminate some wrong answer choices. So here we have a choice A. It conveys Dr. Markova's lack of interest in continuing to support new programmers. Well, no, the passage literally says she welcomes everyone. She might be blunt, but she's still supporting them. Choice B, it explains Dr. Markova's view of the quality of technological innovations of the time. There is no mention of what she thinks about technology in general, just that she helps people whether their ideas are good or bad. Choice C creates a contrast between the inexperience of a young developer and the wisdom of Dr. Markova. This might sound good, but that's not what this sentence does. It's saying she's the best path to succeed. It's not comparing her experience to theirs. Choice D, it emphasizes the degree to which Dr. Markova's support is consequential for inexperienced developers. Boom, this matches our summary perfectly, and the passage tells us going to her is the best way to get an idea developed, which shows how important her help is for new programmers. So the final best answer to it is choice D. By breaking it down this way, even if you didn't really understand the passage wholly, you can follow the logic and see why D is the best choice. Imagine if every hard SAT question suddenly felt easy, not because the test got easier, but because you know exactly how to break it down. Most students think the SAT is tricky. The test makers try to confuse us. Yes, but once you learn how they create those hard questions, they become predictable. And right now, SAT questions feel like a magic trick. They seem impossible to solve, but what if someone showed you exactly how the tricks work? Suddenly, it's not magic anymore, it's just a pattern. That's exactly what I do in these types of videos, and if you're interested, you can click the join button below. Well, anytime we have a scaling question like this, we should start by understanding how the scaling affects the map and the distances represented on it. So they tell us that the original map has a width of 60 inches and that 1 inch represents 20 miles in real life. That means the entire width of the map represents 60 multiplied by 20, which is 1200 miles, which is the actual width of the area covered by the map now. They shrink the map by 80%, meaning that the new map keeps the same proportions but is only 20% of the original width. So 60 multiplied by 0.2 equals 12 inches. So the new map here has a width of 12 inches, but still represents the same real-world area of 1200 miles. So the question is asking us, on the smaller map, what's the actual distance represented by 1 inch? Well, if the entire width of the smaller map is 12 inches and represents 1200 miles, you can just divide 1200 by 12, and that equals to 100 miles per inch. So this is just a basic proportion problem where we're shrinking the map, but the real world area stays the same, meaning that each inch now covers more real distance. And notice how the SAT likes to set up trap answers here. For example, choice A, 5 miles per inch, and choice B, 10 miles per inch. And those choices might seem tempting if you misunderstood the problem and assumed everything was shrinking uniformly. But actually, when a map gets smaller, each inch covers more distance, not less, which is why the correct answer has to be a much larger number. And just a quick SAT strategy tip. Whenever they give you a shrinking or enlarging problem, always check if the total world area stays the same, because that's often the key to solving it quickly. So if you saw that the total distance didn't change, then you could have guessed that the new scale had to be larger than 20 miles per inch, eliminating the smaller answer choices immediately. Alright, so let's read the passage. Among the many overlooked artists of her era was Clara Ellison, whose painting exuded an air of quiet brilliance, though few could determine whether this was due to genuine mastery or mere mystique. Her canvases, often obscured by layers of symbolism, seem to hint at an artistic genius that critics could neither confirm nor deny. Her long-lost letters, discovered decades later, might provide some insight into her creative process, but given that they were largely composed of ambiguous metaphors and unfinished thoughts, they might as well have remained undiscovered. Okay, so what stand out here? So few could determine whether her talent was real or not. Critics couldn't decide. The letters didn't really help, they just added to the mystery. And that's the basic sense of it. So let's check out the choices here. Choice A, she has the reputation of a remarkable artist, but it's unclear whether she truly possesses extraordinary talent. Well, okay, so remarkable artist. Yeah, the passage says her paintings had quite brilliance, but unclear whether she truly possesses extraordinary talent. Yep, this matches perfectly with critics could neither confirm nor deny her genius. And I like this choice. It really feels like neutral and it's very hard to prove it wrong. So let's check out the others as well. So choice B, she intentionally avoided public recognition despite making significant contributions to the art world. Intentionally avoided public recognition? Did she do that? No, nothing in the passage says she was avoiding fame. And it's not like she was hiding in a cabin somewhere. It's just that critics didn't know if she was actually good. So I don't really like this one. Choice C, she appeared to be a visionary painter, but her writing suggested some of her work was fraudulent. Fraudulent? It's a super strong word. Did the passage ever say her work was fake? Nope, it just says the meaning was unclear, not that she was lying. And it's a very strong word and there is no proof in the passage. Choice D, she would have been widely recognized if her artistic influences had not been difficult to interpret. Would have been widely recognized? Does the passage say that? No, it just says people couldn't figure out if she was truly great. If her artistic influences had not been so difficult to interpret, the passage talks about symbolism and mystery, but it doesn't say that the reason she wasn't famous. And in the story, there is too much assumption, so that's why that's not a correct answer choice. Now that we know, the final correct answer choice is choice A. The clothing store buys shirts at a wholesale price of $5 each and resells them each at a retail price that is 320% of the wholesale price. At the end of the season, any remaining shirts are marked at a discounted price that is 75% off the retail price. What is the discounted price of each remaining shirt in dollars? So this is such a great question because it has some serious traps, and I would know that going in, first, we're dealing with the percentages, which are notoriously tricky on the SAT. And second, it's a multi-step problem, meaning there is a huge opportunity for you to make a mistake. So if you don't stay careful, you might make a mistake here. So let's break it down step by step. So here we are given that a clothing store buys shirts for $5 each. Then it resells them at 320% of the wholesale price. That off is really important because it tells us that we're not just taking a normal percentage of a number. That means we use this formula. New price equals original multiplied by a percentage as a decimal. The original here is $5 and 320% as a decimal is 3.20 because we move the decimal 2 places on to the left. So 5 multiplied by 3.2 would equal to 60. So the retail price of the shirt is $16. But you're not done yet. There is a second step that you should take. Any remaining shirts are marked at a 75% discount. Now the phrase 17% off is very different from saying 70% off. This is where a lot of students get trapped because off means we subtract that percentage from 100. So instead of multiplying by 0.75, we multiply by 1 minus 0.75, which is 0.25, because 75% off means you're only paying 25% of the original price. So $16 multiplied by 0.25, and that equals to 4. So that's our final answer, $4 per shirt. And if you wanted to do this all in one step, you could have done 5 multiplied by 3.2 multiplied by 0.25 and you would get 4. But since these percentages can be tricky, I highly recommend you to break it down. These SAT prediction questions don't matter if you don't have specific strategies for every type of SAT question. And in this video right here, I explained everything that you need to know for the SAT reading section. So make sure to check that video out.